All right, so let's take a look at the three possible gas laws you can use. All right, so we have the overall combined gas law. P1 V1 over T1 is equal to P2 V2 over T2. In the PowerPoint, it discussed that sometimes the variables are held constant. So whenever temperature is constant in an equation, if you simply cover up temperature, again, because it's constant, if temperature is constant, then your equation is going to be P1 V1 equals P2 V2. Because again, when temperature is constant, it is not part of the equation. So your equation will be P1 V1 is equal to P2 V2. All right, so next up, let's say when you're reading your problem and volume is held constant. So if volume is held constant, so we will cover up the variable volume, and then your equation is P1 over T1 is equal to P2 over T2. All right, going back to the original equation. When you are looking at your question, and if pressure is held constant, so you take pressure out of the equation, and so now your equation is going to be V1 over T1 is equal to V2 over T2. You can find this combined gas law equation in the reference table. This is not an equation that you will have to memorize. This entire equation can be found on your reference table, okay? So now let's take a look at the question that you have in front of you. A sample of oxygen gas occupies a volume of 250 milliliters at 700 torr. What volume will it occupy at 800 torr? So if we take a look at all right, so when you take a look at the equation, we start with the original P1 V1 over T1 equals P2 V2 over T2. When you look at what is given, it gave you a volume of 250 milliliters. All right? It also gave you a pressure of 740 torr. Then it says what volume will it occupy. So because it's saying will it occupy, it's talking about in the future. So that's going to be your second volume. So we then can interpret that this is going to be P1 and that is, this is V1, that's P1, and that our P2 is 800 torr. Again, so volume is your V1 is 250 milliliters, your P1 is 740 torr, your P2 is 800 torr. You are solving in this equation for V2. So when you look at this equation, we go back and look, well, what is held constant? Well, go ahead and assume that temperature is held constant for this problem since it was not mentioned in the question at all. So I'm going to take out my temperature variable. So now this goes back to your algebra, and we're going to set this equation up so that we are solving for V2. So with this, we can divide both sides by P2 because we need to isolate this variable. Okay, so let me make more room. So when you divide both sides by P2, you get V2 is equal to P1 over V1, P1 times V1 over P2. Now you're going to go and plug in your numbers so that you can solve. So we know P1 is 740 torr. V1 is 250 milliliters over our P2, and we know P2 is 800 torr. So you're going to multiply 740 torr times 250 milliliters, then divide by 800. And as we look at this equation, we know that our torr will cancel. So you're going to plug into your calculator 740 times 250. Then you're going to divide by 800. And your final answer is 231 milliliters. Now, we can check to make sure that this problem was worked out correctly. So, if you remember back in the PowerPoint, we discussed when you have pressure and volume, this is an inverse relationship. So we went from, in the problem, 250 milliliters to 231 milliliters. And then the initial pressure was 740 torr. The final pressure is 800 torr. So taking a look at this, going from P1 to P2, there is an increase in pressure. Therefore, our answer shows correctly that when we go from V1 to V2, that there's a decrease. So again, please remember that when you have pressure and volume, that there is an inverse relationship. That is a way that you can check your work. Another way we can look to solve this problem is if we look at the ratio between P1 and P2. So if I do 740 divided by 800, that will equal 0.925. So I can take this 0.925 and multiply it times the volume. So I can do 250 times 0.925 to get the same answer of 231 milliliters. So either way will get you to the same result. You have options as to how you want to work out the problems. Pick whichever one works best for you and go with it.